Okay, part two. We're talking about air resistance and terminal velocity. So terminal velocity depends on not only the size, shape, and mass of the object falling, but how fast it's going to be going pulled to gravity. And so we can see here, so if we have a person falling due to gravity equals 100 newtons. Now, we know that the acceleration rate at which they're being pulled down is going to be 10 meters per second squared. It's because it's reached 1,000 newtons. It weighs 100 kilograms, so it's 1,000 divided by that 100 to get that downward terminal velocity of acceleration of 10 meters per second. The increasing speed increases air resistance until force of air is equal, which is force of air resistance equal to force of gravity. And so, falling with air resistance. The heavier the object is, the faster they accelerate to a higher speed to reach their terminal velocity. So the larger the object, force to gravity is equal to force to air resistance a lot quicker than a smaller object. Well, if we take the elephant and the feather, the elephant's going to hit the ground first because it doesn't have as much air resistance acting on it. And so it's going to reach that terminal velocity a lot faster than the feather will. Mainly because the larger force due to gravity, you need a larger air resistance, and you just don't have that with the elephant there. And then it would reach a higher speed, much quicker. So, what force would be required to accelerate 40 kilograms mass by 40 meters per second? So you are going to work these out in your groups. And so if you want to grab whiteboards, you can grab whiteboards. Right now we're going to go through a couple practice problems. Okay, so first off, remember the equation they're going to use is force is equal to mass times acceleration. So you can actually work that out right now. So you can pause the video and go ahead and work that out. Okay. Here's what you're given. You're given mass and you're given acceleration. You are not given force. You have to find that. So in this case, you are going to take force is equal to mass times acceleration, so 40 kilograms times 4 meters per second squared. And you are going to get an answer of 160 newtons. So I hope that you got that when you were working this out. Let's do another one. So, a 4 kilogram shot put is thrown with 30 newtons of force. What is acceleration? Go ahead and pause this right now and you guys figure that out in your groups and we'll see if you're right. So here's what you're given. You're given the mass, you're given your force, and you need to find your acceleration. So, acceleration is equal to force divided by mass. And so you want to take your 30 newtons divided by 4 kilograms, and you should have gotten an answer of 7.5 meters per second squared. Remember, if you're not given your kilograms and you're given grams, you need to convert kilograms to grams. And there's always 1,000 grams in 1 kilogram. Okay, here's another one. Jane weighs 557 newtons. What is her mass? Alright, so remember you can use the equation weight is equal to mass times acceleration. It's the same as force is equal to mass times acceleration. You can pause the video right now and go through this. Okay, you're given force and acceleration. Acceleration is due to gravity, so you should know that it's 9.8 meters per second. If she's falling, you should know that. Or if it's asking for mass, you should know that too. So we are going to find her mass. So here you go. Mass is equal to force times force divided by acceleration. Mass is equal to 557 newtons divided by 9.8 meters per second, and you get a total mass of 56.8 kilograms. So I hope that you got those problems and they weren't too crazy. If you want to write down these reworked problems right here, you sure can go ahead and do that right now. All right, I hope you guys have a good day. Talk to you later.